Hey guys, this is Mrs. Mooney, and this video is about literal equations and inequalities. So when I say literal equations, I'm talking about literal as in with letters, and literal being more than one variable. So we've got x's, y's, a's, b's, whatever. And when you have a literal equation, you're going to be asked to solve for one of those variables. And if I say solve for b, then I'm saying to rewrite that equation with just that one variable on the left, basically, and everything else on the other side of the equal sign. And that variable that you're solving for will not be on the other side of the equal sign. For our first example, we're going to use the formula for the area of a triangle. We're going to solve a equals 1/2 bh for the height. Then we're going to find the height of a triangle with a base of 4 inches and an area of 18 square inches. So what you're going to do is you're going to take this literal equation that has 3 different variables in it, and we are going to first take care of that 1/2. So if I have a equals 1/2 bh, then to get rid of it, we're going to multiply both sides by 2. The multiplication property of equality says that you can do that because those will cancel out. So 2a equals bh. And since we're solving for the height, we want to get our h by itself. We need to undo this multiplication by dividing. And our h is equal to 2a over b. Sorry, that's supposed to be an h. Alright, now we're going to find the height when the base is 4 and the area is 18 inches squared. So we're going to just plug in now. The height equals 2 times 18 divided by base of 4. We've got square inches and inches, so we know we don't have to convert any units. And 2 times 18 divided by 4 gives you 9 inches. And make sure you always write your units when you are doing a problem that has units in it. Alright, here's another one. We're going to use the formula for the area of a trapezoid. We're going to solve a equals 1/2 times b1 plus b2. And please note that these are subscripts. They're not like exponents. They're not something you would multiply it by. They're just little subscripts. So that's just saying the first base and the second base, and then times h. And we're going to solve for b1. So what we're going to do first is we're going to get rid of the 1/2 just like we did before. So we can make it 2a equals b1 plus b2 all times h. And so since we're working our order of operations backwards, the next thing we need to get rid of is this h. And the way you would do that is to divide both sides by h so that they cancel over here. So now I have 2a over h equals b1 plus b2. And if I want to solve for b1, all I need to do is move the b2. So I've got b1 equals 2a over h, and then we took away b2. And that is that. Here's a fun one. We're going to solve bx plus ux plus ch equals er for x. So this one is all letters, and we need to get x all by itself. So what we want to do, and pay close attention here, we have x in 2 different terms. So what we want to do is take these 2 terms and we want to factor out the x. It's like the opposite of distributing. So we're going to put the x out to the side and then put b plus u. Think about that. If I were to distribute the x, I would have x times b as bx, and I would have x times u as ux. So I factor out the x, and then I have b plus u, and then plus ch equals er. So the next thing I want to move is the ch, and I have x b plus u equals er minus ch. And then, since I just want to get x by itself, and this is all a group that's being multiplied by x, I can just divide by that same group, b plus u, and divide this by b plus u. So I now have x equals er minus ch all over b plus u. Here's another example. Solve x over m equals a plus h minus x all over m. Solve it for x. So here's another one where x is in here more than once. We need to get it all by itself. So what I'm going to do is I am going to first get rid of this m in the bottom. I don't want fractions. So to get rid of a fraction, you multiply everything by the denominator. As long as you multiply everything in the equation by that denominator, So I'm just going to put it out in parentheses. X over m equals a plus h minus x all over m. You distribute it to this and this and this, then it's still equal. So now if I distribute it to the first one, they cancel out and I get x equals, and then m times a would be ma, and then times the second group, the m's would cancel, and I'd have plus h minus x. So now what I need to do is take this minus x, and I'm going to basically combine like terms, so I'm going to add x to each side. And x plus x gives you 2x. So 2x equals ma plus h. See what I'm doing here? And then x equals, we're going to divide it all, and you have to do every single bit of it, ma plus h all over 2. Cute, huh? Alright, and this last example we're going to do is not technically a literal equation. It only has one variable, so we're going to solve it for x, but it's got some processes that I want you to think about, and that is because we've got a 5 here and a 3 here. So in the last problem that we did, we multiplied everything by m to get rid of our denominators. In this case, our common denominator is going to be 15. So we're going to multiply everything by 15. I'm going to take 15 times 2x. I'm going to multiply it also by this group, 3 parentheses x minus 1 all over 5. I'm going to multiply it by negative x over 3. And I'm going to multiply it by the 4. All of it. So 15 times 2x gives me 30x, sorry. And then if I take 15 times 3 and divide it by 5, I get 9. So 9, and then the x minus 1 stays in parentheses. And then when I multiply 15 times x and divide it by 3, I have minus 5x. And 15 times 4 is 60. So now I don't have fractions anymore. Now I have something that's really easy to put together. I want to distribute my 9, so 30x plus 9x minus 9 minus 5x equals 60. And we want to combine like terms. So the 30x, the 9x, and then the minus 5x gives me 34x. And then I'm going to add 9 to both sides, equals 69. Then we divide both sides by 34, and we will have an x value of 69 over 34, which actually does not reduce. If it reduces, you are required to reduce it, but if it does not, well, then that's it. I'd rather see a fraction than a decimal. Now, is there a way to check this? Of course there is. All you have to do is go back to the original and plug it in here and here and here for x and make sure it works. So whenever you're working through problems, if you have the time to check your answer, you really should do that, just in case you did something silly along the way and you got the wrong answer. Okay, here's another one for you. You guys can do this on your own. I think you can handle it. Alright, so when I said last example, I really meant last example of the literal equations. We still have to talk about inequalities. So a linear inequality is one that can be written where a and b are real numbers, a does not equal 0. Basically, it's a linear equation, like ax plus b, and then instead of saying equals something, it says less than something. We'll go with 0, or greater than, or less than or equal to, or greater than or equal to. A compound inequality is one that has two simple inequalities joined by and or, like x is greater than 3 or less than 5, something like that. And the solution to an inequality is any value that, when substituted for the variable, results in a true statement. So it's not just one specific value, it's a whole range of values that will make that expression true. And then finally we want to define a solution set. And a solution set is when we have a range of answers, because inequalities have more than one answer, we write them in brackets. We write the lower bound listed first, and then a comma, and then the upper bound. So it's like writing a domain or range. We use soft brackets when the bounds are non-inclusive, and hard brackets when they're included. Okay, so here's an example. We have this inequality, 4 minus 2x, it's linear, is greater than 6. And we're doing this for reals. That's the domain of our answers. So basically anything except imaginary, which we're not going to do. Alright, so when we solve an inequality, we do it just like we would do an equation. We're going to subtract 4 away from each side. So we've got negative 2x is greater than 6 minus 4 is 2. Then we're going to divide each side by negative 2. And remember, when you do an inequality, you always switch the sign when you divide by a negative. So now we have x is less than negative 1. Alright, so all x's that are less than negative 1 will satisfy this original inequality. So we're going to graph our solutions on a number line now. And the way we're going to do that is at negative 1, we're going to put an open circle. And you can do it on the number line or you can do it above it. Sometimes it's easier to see if you do it above it. But it needs to be an open circle. And then we're going to shade everything that is less than that. So we're going to go to the left and put an arrow because we're going to the left. So this red ray here represents all of the solutions on the number line that satisfy this original inequality. And we're going to write it in set notation. So our solution we're going to say the lowest amount that it could be. If there's an arrow, that means it's going on down to negative infinity. So we're going to put negative infinity. Then we're going to put a comma, and then we're going to put the highest amount it could be, which is negative 1. And then, if it is non-inclusive, we use soft brackets, which are basically parentheses. So we're not including negative 1. There's an open circle on it. And we're not including negative infinity. We never include the negative or the positive infinity because that's not actually a value that you could touch. And remember, because I see this all the time, write your solution from least to greatest. All right, for this example, we've got 8 and then parentheses, 2x minus 1 is all greater than or equal to 11x minus 17. And this time we're going to solve it in the domain of integers. So first thing we're going to do is distribute the 8. We'll have 16x minus 8 is greater than or equal to 11x minus 17. Then we want to get all the x's on the same side. We want to combine like terms, so I'm going to subtract 11x from both sides. 16 minus 11 is 5x. And I want to add 8 to both sides, so I have greater than or equal to negative 17 plus 8 would be negative 9. And then we can divide both sides by 5. So x is greater than or equal to negative 9/5. Alright, so now we want to graph this on a number line. We need to find negative 9/5. That's almost negative 2. So if I put negative 2 right here, then negative 9/5 would be right here. I don't know, about right here. Make sure you label it. And then negative 1 can be here, and 0 can be here. And we're doing x is greater than or equal to. So if I was shading everything, I would start at negative 9/5, and I would put a closed circle. And then I would shade everything to the right. However, I'm not going to put a closed circle because I am limited to only the integers. So all I'm going to do is put a dot or a closed circle on every integer that is to the right of that spot right there. So the first actual one we will have is negative 1, and then 0, and then 1, 2, 3, 4, and everything on out. So I'll just color the arrow to indicate that it keeps going. And then when I'm writing my solution, I'm going to put it in fancy brackets or braces because I'm not doing a range of values. I'm doing a set of specific values. It's only negative 1, only 0, not the stuff between, only 1, only 2, and then you can put ... infinity to indicate that we keep going with our integers. Our next example says negative 5 is less than 2x plus 3 is less than 15 for all reals. So this is a compound inequality, and when you have a compound inequality, we need to make sure that we're treating it like it's an equal sign or here and here. Whatever we do to the inner part of the inequality, we have to do to both outer parts. So we're going to take away 3. And when I say from both sides, I really mean from all 3 sides, because you're going to have to take it away on this side, and you're also going to have to take it away on this side. So negative 5 minus 3 would be negative 8 is less than 2x is less than 15 minus 3 is 12. And then we have to divide everything by 2. So we've got negative 4 is less than x is less than 6. So that is our compound inequality. On the number line, we're going to graph everything between negative 4 and 6, and since it's for reals, it'll be everything in between. At the negative 4, it's less than but not equal to, so I'm going to put an open circle. At the 6, I'm also going to put an open circle. And then x is everything in between. So we can just shade everything in between, or you can draw it up above like that. Either way is fine. When you write your solution, you're going to say the solution is the lowest value is negative 4, the highest value is 6, and since we don't touch either of those, it's soft brackets. Okay, our next example, we've got x plus 7 is less than 4, or 7 minus x is less than 1. So that's a compound inequality, and we're doing this for reals. So we're going to just solve each one. We've got x is less than 4 minus 7 is negative 3, and then we have negative x is less than 1 minus 7 is negative 6, and then we need to divide both sides by negative 1 and switch the sign. X is greater than 6. So we have 2 parts to this. When we put it on the number line, we're going to have 2 different parts that we draw. We have x is less than negative 3, so we're going to put an open circle at negative 3, and then less than is left. And we have x is greater than 6, so we're going to put an open circle 1, 2, 3, 4, 5 at 6, and greater than goes to the right. So we have 2 parts to this. And then when we write our solution, you're going to do a soft bracket and negative infinity, and then the right-hand side of this is negative 3. It doesn't touch it, so you put a soft bracket. And then you're going to do another soft bracket, because this is also open, 6, and then infinity on the right there. You have to do it from least to greatest, and sometimes you can put, you might see a U in between, U for union, 6 to infinity. The U is not required. If you like it, put it. If you don't, but just if you ever were to see that, that's all it means. And this is called a disjunction. Are y'all tired? I'm tired. That was a long video. I'm sorry. It won't usually be that long, but we had a lot to cover this time. So y'all have a good night. See you tomorrow.